Last time we talked about generics, and this time I want to explore another concept, which is interfaces. But before we talk about interfaces, let's have a look at the sample code. So we have a create user handler. It takes an input, which is a name, email, and password. And what we want to do here, we want to create a user. So we go through a few steps, like we unmarshal the request payload, we validate it, and then we want to save the user to the database, and we want to send a confirmation email. So this we even have a test, so we have two test cases: a success scenario where we pass all the data that is needed, and a bad request scenario where we only pass the name and the validation should fail. So if we run this test, we can see that everything passes, everything is green, but the problem is that this implementation, the actual saving of the user database is missing, and the confirmation email sending is missing. So in real case scenarios, maybe this functionality, the saving the use of the database, is done by another team, or maybe it's not ready yet. So what we can do is we can use interfaces. Interfaces are abstraction types that define set of methods and their signatures without providing any implementation. You can think of it as a contract that your module should follow. So let's try and make one interface. I'll go here, we have services, so I want to create a new user service. I'll do users.go. So this will be, so how do we define an interface? We make type user service, and we want to say that this is an interface. For the moment, we care only for one method. We want to have one method that is create user, and we want to expect that this method will return an error. So in order to use an interface like this and pass it here, we usually wrap this one in a wrapper. So what we do is we make function get create. Let's do it like this. So this one will take an input that is user service and it's going to return a function that has this spec. And here we have so what happens now is when we say create user handler, we'll pass the user service, and then in the actual handler, which is this inner function here, we'll be able to use the service. We need to modify the test a bit to do it. So we'll say that handler equals to create user handler. For the moment, we'll just pass new as a service, and then instead of that, we'll call the handler with the writer and request. And if we run the test here, we see everything is still green. So what do we do now? What we want to do is, let's say we want to save the user to the database. We want to say that error is user service create user, and then if error is not new, then we want to return an internal server error. Okay, of course this doesn't make sense because we're not passing any attributes, any values. So let's go back to the user service and yeah, let's create a user struct. It will have, we don't need the ID at the moment, but we need the email and password. So again, when we call this one, we'll say users dot let's call it create user input. That will make more sense. So this is the create user input, and this one will take the name, input email, input password. Why isn't it happy? Oh, because it doesn't know, so it will take input here, create user input. Okay, everything looks good. The problem is that now if we run our tests, we'll see that they are failing. And they are failing, you'll see, yeah, it's a new pointed reference because this, we're not sending anything as a user service here. So when we try to make the create user call here, it breaks. Okay, but we don't really want to implement the functionality yet. Also, if we implement it, that means that in our test we need to think about things like, is the database there? Like we need to create a whole set of environment around this to make the test work and have actual connection to the database. What we want to do is we want to make a user. We want to make a test that verifies that this method will be called, that this method is called correctly, but we don't care about the actual implementation. So we can do that in a really nice way. We can use mocks. So mocks are fake implementation of an interface or others, the object, that allows us to verify a certain behavior, simulate a certain behavior without actually caring for the implementation. What we can do is we can go to interfaces, services, users. So currently we have just the users.go. We want to create the mock. I'm using decoupled mock again. So the command is pretty much like this: dash source equals to users.go dash package equals to users and dash destination equals to users underscore mock.go. So practically we say which is the source file, which is the package, and where we want the mock to be created. And if we run this one, we'll see that there's a new file created here that will provide us with a mock and a way to test it. I have also made an alias for this one to simplify it, so I can do just go mock users.go, which will make the same thing. I'll add this to the repository later if you want to take a look. So we have a mock, but how do we use the mock? Let's go again to our test. Currently we're only interested in the success case. So first we need to create a controller. So controller is go mock new controller from T. We always need to defer controller dot finish. Yeah, let's import that one. So this will be GitHub github.com slash that's Uber go mock, if I remember correctly. Okay, yeah, sorry about that. I figured out I don't really remember the import, but yeah, the import is gouber.org mock go mock, so we can fix this missing dependency here. Everything looks good. So now we have the controller and it's time to actually create an instance of our mock. So you can say that user service is users dot new mock service control. So here we take the user service and we pass it here instead of new. So now if we run our test that it's supposed to succeed, it will fail again. And the reason why it fails is that it got an unexpected call. So practically we need to register our calls to the mock. Let's do this by updating the test. So this here is a standard practice in Go. It's called table test. So practically you define a bunch of different test case scenarios and you execute them one after another. So what I want to do here is I want to add a function that is setupMox. This will be a function. And then for each one of those, I want to say that in the specific scenario, this one will be function, and what I want this function to do is I want it to take the user service mock. Okay, yeah, we need to move this a bit up. So we'll take the user service. I like to have those named properly. So user service mock, and we want to set some expectation. So what do we want to expect? We want to say that it will have an input that's create user, that receives user dot create user input. We want to say that it's going to receive these values, and we want it to return new, like no error, everything is fine. So if we run this test scenario again, we'll see that, oh, it fails again. So what's happening? Oh, we are not calling this function. Yeah, that's the problem. So we get back here. We want to do if test case dot setupMox is not new. We want to run the mocks. So now if we run this again, okay, it's all green, great. So this way we can verify that we get a proper response when this method here works correctly and if there is no error. So let's also try to add another test case scenario, right? So let's say we want to add a test case scenario for unable to create user. We'll have the same payload. I think we can copy the whole thing. So here we will expect an internal server error. We'll pass the values, but here instead of new, we'll return errors, a new error. Something went wrong. So if we run this test again, we'll see that it actually passes. Oh, it's green. Everything is correct, because in this case, when we have an error, we'll set the internal server error and we'll return. Okay, so that's pretty much how interfaces and mocks work. The tool, the Uber Go mock, it's actually an updated version of the original Go mock that is no longer maintained. So have a look at it, it's really good. How does the interface improve our testability? Now we are able to test the actual behavior of our function. We want to verify this part without worrying about the implementation. We can use this contract that we defined in the interface here as a way for when we start implementing the actual service, we just need to create something that follows this contract. We can, if we look, yeah, let's try and do this. If we run the test with coverage, you can actually see here that all these scenarios are covered. The case when there is no error, the case when there is error, so everything is really good. Unfortunately, unit tests are not enough. They are a really nice way to go during the phase of development when things are not implemented yet. They also help us a lot during refactoring, but they are not enough. They are not enough because there's no real code to the database. There's no real creation of the user. So it's hard to verify that everything works. For that for that purpose, it's good to also have integration tests. We'll talk about this in some other time, but the the truth is that no matter that they don't verify the internal behavior, they actually verify the part that we're interested in. They verify that this one is working. Thank you. Okay, so one more thing. Now we have our user's interface, but how do we actually, we have the user interface, we have the mock, but how do we make a real implementation? So you just need to create a struct that implements this interface. What does that mean? Let's try like this. Let's do type MySQL user interface struct. So, and if we create a function new user service that's supposed to return a user service, and we return this struct, you can see that it's red. The reason why it's red is that it says, oh, it does not implement the user interface. So to implement that, it's pretty easy. You just create a function that takes the service onto my and implement this method. You can have something really simple here, like just print line, this is implementation of create user. You can implement this one. We need to return new at the moment, and it works. And then you can use the new user service everywhere where you need to implement that one. So here, instead of the user service mock, you can say users dot new user service. You can see that it works. If we run the success scenario, that one will be working. Oh, it doesn't work because it expects the expectations are not met. So we set some expectations on the mock, but we never really called it. So, but yeah, if we don't have the mock, we can see that it's green because our service works, and it even prints this implementation of create user. So this is it about interfaces. They're really convenient. They're really great. So have a look, think about them. Oh, maybe one last thing, when to use interfaces. Use interfaces when you want to decouple your code. Use interfaces when you don't have an implementation yet, or when you expect that the implementation may change. If you have something simple like a library that does math operations and so on, maybe interface is not needed because there is no real need to mock it. This is something that you can easily verify and test. But if you have something that talks to other systems, something that it's not really clear, or that has like a really complex internal mechanics, then use interfaces to decouple your code and simplify your tests. Thank you very much for listening, and see you next time.